Alright, so this question is slightly trickier. So you need to prove in this question that n that any knowledge about n is independent of the information you have from two different points on your polynomial. So if two different people get together with their secrets S1 and S2, then it is still not enough information to construct n. And it's not just not enough information, it's essentially no information, in the sense that you have n is equal to 0, 1, 2, 3 to be equally likely. Oh yeah, in this question, take note that you have only 4 choices for n. So it's, you know that the people know that n cannot be 4. So they have a smaller number of things to choose from. And still, n is equal to 2 is independent of these two events. Let's go about proving that. Alright, so we have, again, let's construct linear equations from these two equations we have. So we have S1 is equal to 2, which means that n plus k plus l, right? It's n times k times 1 plus l times 1 is equal to 2, right? And then we know S2 is equal to, what is it, 0. Therefore, you know that n plus 2k plus 4l, which is n plus 2 times k plus 2 times l is equal to 0, right? This is the definition of what the secret is. Again, this is mod 5. So from these two equations, let's try to get a relation between n and k and n and l, so that later we can easily calculate and we can easily work with these, right? As in when we're given a value of k, we know exactly what the value of n will be. When we're given the value of l, we know exactly what the value of n will be, right? So let's just try to work with that. Now, for that, let's take the first equation. Let's name this equation 1 and equation 2. Let's take the second equation and subtract the first equation from it, right? Or rather, actually, we want to remove L from the system, right? We want to find a relation between n and k. How do we remove L from the system? We can either take the first equation and subtract we can either take the second equation and subtract the first equation 4 times, which means L and L will get cancelled. But you know we're working in mod 5, right? So if we just add these two equations, then the coefficient of L will become 5. If the coefficient of L becomes 5, then you know it's equivalent to 0. So let's just add these two equations, which is equal to n plus k plus L plus n plus 2k plus 4L is equal to, I'm just going to write is equal to, I'm just going to put everything into the next line and say this is equal to 2n plus 3k plus 5l, which goes to 0, is equal to 2, right? Therefore, what do you know about this? K is equal to, let's take k to the other, let's take 3k to one side and say is equal to 2 minus 2n. This is still mod 5, right? Mod 5. And I'm assuming again that everything down here is mod 5. So you have 3k is equal to 2 minus 2n. And let's multiply both sides by the multiplicative inverse of 3. And that is 2, right? Because I showed you that earlier. Times 3 is equal to 4 minus 2 times 2n, right? This is k is equal to 4 plus negative 4. What is negative 4 mod 5? It's just 1, n. So it's just 1 times n mod 5. Therefore, we know that k is equal to n plus 4. I'm just rearranging that. K is equal to n plus 4 mod 5. So what do we show? I've just erased everything to start again. We've shown that, I wrote that a little bit too big, didn't I? So write that small here so we have space to work with. K is equal to n plus 4 mod 5, right? Because I'm just going to assume that these are just following the same pattern, mod 5. Okay, so now you want to find out what L is in terms of n. Right? Now how do we remove k from the equation? What we did last time was we added these two and we saw that the coefficient of L became 5. Now how do we do the same thing for this? Well, we see that we can just add 3 times the first equation to the second, and then we can get rid of k entirely from the equation. So let's go 3 times 2 plus 1 is equal to 3n plus 3k plus 3l plus 3n, no, oops, this is not 3n, this is just n, plus 2k plus 4l is equal to 3 times 2 plus 0, which is 6, right? And now let's just cancel these out. This goes to 0. 3 plus 4 becomes 2, right? So now we have, 4n plus 0 plus, so let's just write that down, plus what is 7l? What is 7l mod 5? It's just 2l. Which is equal to what is 6 mod 5, which is just 1. Right? So our equation is 4n plus 2l is equal to 1. Again, let's do what we did before. Let's take 2l is equal to 1 minus 4n. And let's multiply both sides by the multiplicative inverse of 2, which is 3. So 3 times 2l is equal to 3 times 1 minus 3 times 4n, right? Because 3 times 2, I'm just going to mention this is equal to 6, which is equal to 1 mod 5. Therefore, 3 is the multiplicative inverse of 2. So now we have L is equal to 3. What have I done here? 4. Okay, that's what I missed out. So 3 times 4, it's 12, which is negative 12, right? What is negative 12? You add 5 thrice, right? Basically, what is negative 12? Is equal to negative 7, is equal to negative 2, is equal to 3 mod 5. So we have negative 12 is equal to 3 mod 5. Whoops, that's untidy. Alright, so now what we now these are our two equations. So we have L and K in terms of n. So given n, we can find L and K, right? So now let's look at our 4 different possibilities of n. N can be equal to 0, 1, 2, 3, right? Let's look at our 4 options. Let's say n is equal to 0. If n is equal to 0, k is equal to 4, L is equal to 3, right? This is option 1. Let's look at option 2. I'm just going to segregate these into 4 options. So n is equal to 1. Now we have k is equal to 0, because k is equal to 5 mod 5, which is 0, right? And L is equal to 3 plus 3, which is 6, which is L is equal to 1 mod 5, right? Now we have n is equal to 2. Alright, okay, that's nice. So we have n is equal to 2, then we have k is equal to 1 mod 5. When n is equal to 2, 3 times 2 is 6 plus 3 is 9, so L is equal to 4 mod 5. Then we have n is equal to 3, when n is equal to 3, k is equal to 7, which is equal to 2 mod 5. And 3 times 3 is 9 plus 3 is 12, therefore L is equal to 2 mod 5, right? Therefore these are our different values n can take, different values k and L can take when n takes a particular value. And now we want to show that any given value, if you find any point from S1 and S2, if you find 2 points, we still don't know anything about n. Therefore the probability of n is equal to 0, is equal to 1, is equal to 2, is equal to 3, all are going to be equal, and they're all going to be equal to 1 over 4. That's what we're going to prove now. Alright, so now we want to show that the two events are independent. Therefore we want to show the probability of n is equal to 2 is times probability of S1 is equal to 2 intersection S2 is equal to 0 is equal to probability of n is equal to 2 comma S1 is equal to, or intersection, let's just put that as intersection S1 is equal to 2 intersection S2 is equal to 0, right? We want to show that this times this is equal to that. That's the definition of independence, right? So now let's just find the probability of n is equal to 2. What is this equal to? So now we see that how many different ways can we have. So let's just look at our initial equation. N is initially determined by rolling a fair four-sided die. That's difficult to say. It's a fair four-sided die. So the probability that it lands up in any given one of 0, 1, 2, 3, or 4 to begin with is just 1 over 4. Therefore, the probability of n is equal to 2 is just probability of it landing 0, 1, 2, or 3, because it's completely fair, which is 1 over 4. Right? Now let's look at the probability of S1 is equal to 2 intersection S2 is equal to 0. Because initially what happens is that the person who rolls these dice, they roll S1, or they roll the number for K independent for the number for L. Actually, let's just not look at it that way, right? This is because we just computed whatever we have here. Let's just actually use that in the equation here, right? So probability of S1 is equal to 2 and S2 is equal to 0 is equal to probability of N comma K comma L is equal to, so we just calculated there are 4 different possibilities for N, K and L to give S1 is equal to 2 and S2 is equal to 0. Therefore this is equal to 0 comma 4 comma 3 or 2 comma 1 comma 4 or 1 comma 0 comma 1 or 3 comma 2 comma 2, right? So the probability that S1 is equal to 2 and S2 is equal to 0, as we calculated previously, are if N, K and L take one of these 4 values. So now what's the probability that it takes any one of these 4 values? Any one of these 4 values. So we can just take, because N, K and L are generated independently, so each and every one of these values should have the same probability, right? Because if you like, okay, let's just look at it, let's just actually calculate it out. Okay, yeah, so let's just go ahead and actually compute the probability that P of N comma K comma L is equal to just 0 comma 4 comma 3. What is this? So because N, K and L are rolled as 3 independent dice, they are independent of each other. So the probability that N is equal to 0 is independent of the probability that that K is equal to 4. Therefore this is equal to the probability of N is equal to 0 times the probability of K is equal to 4. I hope you understand why this is the case, because the dice which are rolled for each and every one of these are completely independent of each other, and therefore they don't influence the outcome in any way of the other dice, right? What is N is equal to 0? As we showed before, it's 1 over 4, because each and every one of those 4 possibilities are equally likely. The same way, K is equal to 4 is 1 over 5, 1 over 5, which is 1 over 100, right? So now we have the probability of this sample, or N, K and L taking these 3 values, is equal to 100. Alright, and just in case you guys have a case of engineering OCD, I completely forgot to do this. Whoops. Okay, so now we found that probability of N is equal to 2 is equal to 1 over 4, probability of N, K, L is equal to 0, 4, 4, 3 is equal to 1 over 100. Similarly, probability of N, K, L is equal to 1, 0, 1, just as we computed for that, is equal to 1 over 100, which is also equal to probability of N, K, L is equal to 2, 1, 4, which is equal to probability of N, K, L is equal to 3, 2, 2, right? So all these are the same. Therefore, the probability of all these happening together, that is probability of N, K, L is equal to 0, 4, 3 or 1, 0, 1 or 2, 1, 4 or 3, 2, 2 is just, the probability of this happening is just 1 over 100 plus 1 over 100 plus 1 over 100 plus 1 over 100. Why? Because each and every one of these events are disjoint, so when one happens, the other cannot happen, right? Therefore, you just add up all these and you get 1 over 25, which is just 4 times 1 over 100, right? Alright, so I've written down everything which we know so far. We know that probability of N is equal to 2 is equal to 1 over 4. Probability of N is equal to 2 intersection S1 is equal to 2 intersection S2 is equal to 0 is the probability that N, K, and L land as 2, 1, and 4, which is 1 over 100. Then the probability of S1 is equal to 2 intersection S2 is equal to 0 is the probability that N, K, and L land as any one of these 4 sets of values, which is 4 times 100, 4 times 1 over 100, which is 1 over 25. Do we have enough information now to know whether the event N is equal to 2 is independent of the event S1 is equal to 2, S2 is equal to 0? let's find out. What is probability of n is equal to 2 times probability of s1 is equal to 2 intersection s2 is equal to 0. What is this? Just from above we have 1 over 4 times 1 over 25, which is equal to 1 over 100, which is exactly probability of n is equal to 2 intersection s1 is equal to 2 intersection s2 is equal to 0. Now this is the definition of independence of two events. When probability of A times probability of B is equal to probability of A intersection B, then we know that the two events are indeed independent. Thus we've proved that the event n is equal to 2 is independent of the event s1 is equal to 2 comma s2, whoops, I'm just gonna fix that comma s2 is equal to 0, and that's all. Finish the proof. That's how to do part B of question 2. Question 1.